Welcome to Relay Chain, a podcast produced by Parity Technologies where we discuss all things substrates, Polkadot, and Web3. Today we have Anna and Deirdre from the Zcash Foundation. Welcome.
Hi.
Hi.
What brought both of you to the Zcash Foundation in the first place?
So I might start. Yes, actually, I'm doing an internship with the Zcash Foundation. And it was actually last year, ZCon, where I was talking to the Zcash Foundation. And I was like, oh, I'm really interested. And your work is great. And, maybe. And so this is how I ended up with the Zcash Foundation. And I'm happy I am doing this internship, actually.
Okay, so what brought you to ZCon last year?
Actually, it was, I think, originally a meetup. And then just my cryptography stuff that I was doing and my master thesis that I was doing. And I was like, I need to talk to those people. So actually, I was a scholarship attendee last year. And I was happy that the Zcash Foundation has scholarships available for like people like me or like other people who are interested. That's really awesome.
For myself, I was interested in specifically post-quantum cryptography for the past few years, basically as a hobby, because I was getting more and more into security for my real day job. But my real day job was not related to cryptography at all. And via that, I kept going to conferences like Real World Crypto and DEF CON, Crypto Village, and making friends on the internet who worked in cryptography. And one of them told me that the Zcash Foundation was looking for their first core engineer hire who would be responsible for taking over a Rust implementation of the Zcash protocol. And it was a confluence of interests all in one job. And I went for it and they hired me. And I started 4 weeks ago. And this is my first Zcon.
So Anna, you just helped make the first or the second Zcash implementation, the first one outside of the Zcash company or electric coin company. And Deirdre, you're taking it over. Mm-hmm. So what's the benefit of having multiple clients in the first place?
Well, for any independent protocol, you want to make sure that if any multiple parties are trying to operate over this protocol, if you have a single implementation, it's prone to be a single point of failure. So one, you want to make sure you don't have a single code base that everyone will be susceptible to a bug or a wrong implementation of the protocol. But two, if we want diversity over what running that protocol means, in a more general sense, not just a security implementation sense, having more than one implementation is a very good idea. So for example, the deployment of TLS across the web ecosystem to secure anything over web traffic or internet traffic in general, there used to be I don't know if it's still true, but a lot of implementations were consolidated around a very few number of implementations of TLS, such as OpenSSL. And when a bug happened in OpenSSL, everyone got bit, such as, not everyone, but anyone who was using it that was susceptible to the bug, such as something like Heartbleed. So it behooves us as protocol maintainers, as protocol enthusiasts of Zcash, the protocol, to have more than one implementation so that we can, distribute our risk, as well as we have multiple avenues to develop the protocol as a community so that it's not just one implementation and one version of the protocol getting pushed forward that everyone has to rely on.
Yeah, just in general, like decentralization with only one protocol implementation is kind of ironic. So that's what we try to not do. So that's decentralization with decentralized kind of protocol implementations is what we want to achieve.
You guys gave a talk yesterday and you talked about getting the community involved in the project. But then we had these breakout sessions in the afternoon and we were in different ones. But in mine, some people from the Zcash Foundation weren't even aware that the Zebra client was open source throughout its development. And so they weren't watching it. And so naturally, my next question is if the people in the Zcash Foundation didn't even know about it or follow, they knew it existed, but they didn't know it was open source yet. What are your plans to get the community engaged?
Well, for me, I think that the reason that was true is because we didn't have any engineers or technical people at the foundation who were ready to, take over a project like this when it was done. We have, given grants to other engineers and other developers who would either continue maintaining those projects after they were, done, air quotes done, But this is, I think, one of the first situations with the foundation that a project was done and handed over directly to the foundation. So for the future, I'm basically on Twitter all the time. So I will be like soliciting people to try out new versions, try out new implementations of zips as we upgrade to the new network upgrade pipelines for at least for the immediate future. We will be explicitly advocating to people to go to our open source repo on GitHub, download the code, try to build it, and then eventually we will be distributing packages and binaries and things like that and try them out for us because we are still a small team and we are trying to serve a large community. So we need the help of the community to help us make sure that we are adequately serving them with this implementation. So now that we have a full-time person whose job it is to do Zebra and, you know, push it forward into the future, I will basically be like explicitly asking for help in many different avenues, including Zcon, on the internet, on GitHub, so on.
Okay, so follow Deirdre on Twitter.
Yes. I am at Durham Crustalum. I have an avatar of a chicken wearing a helmet.
Which is actually amazing. It's like on all the platforms, you have the same avatar, so it's nice. You know, we have the Rocket Chat,
yes,
which is also nice for everybody who's like actually like contributing at some point and is contributing to this open source project. They can ask us questions in the Rocket Chat, which is the channel is called Zebra Dev. And actually, it's nice because there's also all the Zcash Wizards also there. So you can there's also a lot of questions just in general about Zcash. And there will be questions about Zebra. And so, yeah, I think there you also have an avatar of the chicken with the hat.
Yes.
The helmet is also there.
Okay, we'll make sure to put links to all these things.
Yes, please. Thanks.
In the show.
Thanks.
So now that we've handed over the client from Parity to the Zcash Foundation, what's the state of it? Like, what can it do and what can it not do yet?
Well, technically, it is alpha software because we, the foundation, just took ownership of a large pile of Rust.
I think like most blockchain software, like Bitcoin and Ethereum, like it's all alpha software.
Okay,
anyway.
well, just to make it explicit, this is alpha software. We're still, making it ready for us, the foundation, to explicitly tell the world, like, okay, go run this on mainnet, put money into it, and that sort of thing. So for my first 4 weeks with the foundation, we were prepping for us to take ownership of it and rename some stuff and basically turn it into Zebra, at least from a branding and kind of community standpoint, but also setting a lot of continuous integration, deployment, and analysis infrastructure. Currently, we are using a GitHub Actions pipeline, but that's still not available to us as a GitHub org. So I'm still waiting to see whether we can do that in the future. But we're also trying to make these builds faster and trying to get a better fuzzer test suite so that we can do randomized analysis and testing of the software. And that'll take a little bit of time for us to generate tests that'll touch a bunch of code. But we also are trying to finalize an audit from my end and an audit from one of our research scientists at the foundation, Henry DeValance, to make sure that we, the foundation, know exactly what this code is doing and what we want to keep and what we want to clean up from sort of a Bitcoin perspective before we turn it into mainnet. So right now, what it does is it runs on mainnet and it runs on testnet, but we don't recommend you run it on mainnet yet, but it works. We don't have, it's operational up through Sapling. We support Sprout and we support Sapling. We are targeting to get implementation done for the Blossom network upgrade by October when it's supposed to turn on, but we haven't started that work yet. We plan to go to release 1.0 before Blossom is implemented, but that's a tentative plan.
There's also like plans on like the RPC things. Maybe like the whole structure is going to be like, we think about how to improve in general, like RPC things. And for now you can do like Bitcoin based RPC. And we're like thinking to extend and to change that. So this is also what we like call like, for example, wallet developers to do is to talk to us about RPC. So if you tuned in and you do something where you need RPC stuff, let us know. And so this is something we are like thinking about and going to do.
So when you say run, like it can obviously sync blocks, but like can you send transactions, shielded or transparent?
Yes.
Can you do everything?
Yes, as far as I know, you can do everything.
Okay.
But we're not recommending that you do that except on testnet for the time being. Yeah. We don't have viewing keys yet, but neither does Zcash to my knowledge. So, yeah.
Viewing keys for what?
For sapling.
For
Okay.
shielded.
Yeah, for shielded transactions and sapling.
It's been a while since I ran Zcash D. It was before sapling,
Okay.
but I know I was generating like the viewing keys and stuff
Oh,
before
okay.
that.
Then okay. Then
But I
maybe
haven't
misinformed.
tried post sapling.
Okay.
So I'm out of the loop.
Yeah. But it's basically also just nice, like syncing, seeing how you actually like see what's happening, and also knowing that there is a second node implementation.
Yeah. Our RPC is currently not as extensive as the one in Zcash G. It's matching up with basically the basic Bitcoin operations over the RPC. We don't have a separate compiled CLI the way that Zcash G does. You usually use curl or something like wget to hit the RPC locally or remotely. Part of our goal is to work with especially wallet developers and see what they need from our RPC, but not necessarily add every single little thing that people might think might be useful sometime down the road. We want to keep it useful, but also like terse, because the more methods that you support, the more complexity in the parsing layer of your RPC, and the less that we have to maintain, the better from a security and complexity perspective. So we want to be useful, but not a kitchen sink of an RPC.
Yeah. Like also like I think one of the like main points is just to have a good secure implementation. So that's why Deirdre is like talking so much about not too much, but very good much about fuzzing and the build infrastructure. And this is just in general, you don't need to have overhead in RPC as well.
Yeah, you're getting ahead of me. That was my next question, because in your talk you mentioned this build, test, deploy, benchmark pipeline. So do you have experience with that in other software? And can you talk about like what each step of that means?
Yes. So the way that our pipeline is currently set up is we run all of our unit tests. We have multiple packages. Thanks to the Parity folks, they structured it nice and cleanly, it's very nice. We have multiple Rust packages at the top layer of our repository, and we run the test for all of those. And then the Zebra daemon, the main binary. If all those tests pass, we do a release build of the whole package. If that works and you're on our master branch, we will package that up as a Rust container image, ship that over to Google Container Registry. And in parallel, we build our Rust fuzzer binaries. When those binaries are built, those are separate tests from the unit tests. We ship those over to a Google Cloud bucket where it gets picked up by our cluster fuzz continuous testing, our continuous fuzzing infrastructure app, which is an open source app that Google released a couple of months ago. And you can set it up on your own cloud, and it will pick up these binaries and put them into a job. And the way that you've defined your fuzzer, it shoves random data into these runners of pieces of your code to see what happens when you just shove random bits into them and executes them.
We're still in the test phase of this, right?
Yes, this is, we have very few fuzzers at the moment. We want to expand that a great deal, because that will basically help us, in theory, automate the generation of tests in a way that manually writing unit tests and having a human think up how to unit test a piece of code or an API, things that they wouldn't just think up on their own. We're going to continue to supplement our existing unit test suite, but in concert with fuzzing. So all of those steps basically let us continuously test for every single change on a branch and to master, whether all the tests pass, whether the build succeeds for the release profile. And then we use that exact same piece of code to ship it to our container registry, and eventually will be auto-deployed to our testnet clusters. And we plan to have testnet clusters of nodes running Zebra in North America, Europe, and Asia at the very least. When we have our specifically released, 1.0 or like major releases that we actually tag and say, this is 1.0 or 2.0 or the release with Blossom support or something like that, we will automatically be deploying those to run on mainnet as well and have clusters hopefully all over the world to help supplement the network.
Do you test with testnets of Zcash D and Zebra at the same time?
Not yet. This is a goal.
Goal also like integration testing, and also like comparing those is like a goal that we need to like achieve at some point.
Yeah.
Yeah. But also like I wanted to add, are we going to have then clusters of zebras, which are going to be Zeals?
Yes. We're going to have Zeal North America and Zeal Europe and Zeal Japan and stuff.
So if anybody's like, listening and does not get the joke about the Zeal, that's the mascot of the Zcash Foundation. Our mascot is a Zeal, which is a group of zebras. So there we are with clusters of zebras.
Yes.
Welcome to Zcon. So when you get to like the benchmarking phase, what are good benchmarks for a client? And also like an individual build, like on a single machine versus a benchmark for clients connected to each other.
Right. So for our builds, it's a little bit of what your actual runtime restrictions are. So for us in doing everything in Rust, I just rhymed. Our builds by themselves with everything cached locally are a lot faster than, say, the Zcash G builds, because a lot of their code is C and C++, and a little bit of Rust cryptography in there. That is thankfully mostly due to Rust and Cargo being quite excellent. And then on top of it, it's how you are distributing your packages, like how you're deploying it, how you're building it for release and things like that. For us, we're doing it right now all in Docker images and containers. And the fact that the resulting builds, the artifacts and the binaries that we actually release are quite large. They're 3 to 4 to 5 gigabytes of just stuff that we build to actually spit out our Zebra binary. Moving that around between clouds over the internet pipes can take a while. So I was able to get our builds down from 40 to 50 minutes in a kind of smart cached Travis CI build. Nothing else about how we cargo test and cargo build release, to 25 minutes on a branch change with a small change. So that was very nice. And a lot of that is shipping bits around on the internet. So there's probably like 10 to 15 minutes of that we can shave off if we didn't have to move gigabytes of data around on the internet. And then in terms of benchmarking, you would like to see how fast it takes for you to validate proofs, to validate generating of your keys, to validate as much as you can that is independent of changing blockchain or public data that comes into your implementation. So for example, you would like to test with constantly held parameters, I guess, into these benchmarks. So if you are always benchmarking your implementation against a constantly changing blockchain, your benchmarks are going to vary because there's activity that you can't control happening on the blockchains. Like people might be shoving like tons and tons of data into certain transactions in certain blocks. So one time you run your benchmarks and they're really fast, and then the next block gets mined and you're just like, what happened to my benchmarks? So as much as you can, you want to structure them independent of the blockchain changing. So you might snapshot the blockchain if you need to bench like processing of blocks and not necessarily running proofs on them. And then you run your benchmarks. And then if you decide to upgrade to a future snapshot in the future, you will have to adjust your benchmarks to take account for that and just be like, oh, we can't compare our results from the past to what we have now because you've completely changed your set of assumptions of what you're testing.
This would be like two different builds of the client, so
Yes.
or two different versions. So you could say like, okay, how do these two compare if we have like this state and then like we
Yes.
just flood the mempool with all these transactions, how fast do they deal with it?
Yeah.
Okay. And an entire network? How do you test that?
I don't have a good answer for that yet because I'm a little bit new into benching like a multi-networked protocol implementation. I have a little bit more experience of just like a single peer to a single peer, such as for TLS or something like that. We'll see. I have a feeling we're going to be running experiments of like a cluster of zebras, a Zeal, and try to have a standalone experiment of them just trying to overload each other and see when they fall over and see like if we can like auto-generate blocks or transactions of like maximum size or something like that and just saturating the peer-to-peer pipes and see what happens. And that's less of a benchmark. It's more of like a load test of like what Zebra can do. And then if we kind of have benches or I guess standards of like what we expect Zebra to behave, we might set up a integrated test environment of Zebras and Zcash D instances and see like if we're trying to do this behavior with Zcash D, does Zcash fall over, or are we the bottleneck? Is Zcash better than us? We'll see. So that's one way to test that.
Yeah, very much. And also we can think at some point have a look at the Zcash testings and timings. They have a whole website up with green, red, orange structures. I don't think we need we will see how necessary that is and how helpful that is. From development perspective, I think very much helpful. But maybe users, they won't check every day. So I'm not sure a live website could be fun. But yeah, let's see.
I think it depends who you're talking about when you say user. Most of this client software, the user is another developer
exactly.
or a company. It's not so many. We're all nerds here, so we use it, but most people don't. So
not the end user who's trying to just pay with Zcash or accept Zcash. We mean people who are going to take Zebra and integrate it into their own software or try to deploy it themselves. Yeah.
Which is hopefully a lot.
Yes.
Yeah, hopefully.
So on the roadmap, Blossom is next.
Yes.
And can one of you talk about what are the main features and upgrades in that?
So there is a single zip in Blossom, and as opposed to Sapling, which was a major overhaul of the proving system and of so many efficiencies and new curves and all sorts of stuff. Blossom has a single zip. There were a lot of other things, as if I recall, that were originally slated to be part of Blossom, and they had to be dropped on the floor because there just wasn't enough bandwidth to implement them in time. I forget what the zip is in Blossom, but I'm pretty sure it's actually quite small in comparison to, for example, Sapling. That's why we are fairly confident in getting a 1.0 release out before Blossom, and then also releasing another version that includes the Blossom upgrade. So,
by the way, what's the name of a baby zebra?
Oh God,
I
don't know.
No
That's
clue.
what you should call it until 1.0.
Yeah, that would have been a good idea.
Yeah.
A child zebra would have been also
A zebrette.
Yeah.
Okay, we'll take this a little bit less technical now. Anna, you're also studying politics and society?
Yes, politics and technology.
Oh,
but I mean, that's kind of
politics and technology.
Society is technology in most cases.
Yeah. So what do you think will be the political and changes due to this technology?
So you mean technology in the sense of cryptocurrencies in general, or technology in the sense of privacy preserving technology, like general cryptography, for example?
I was thinking more general cryptography.
Okay,
but,
that's good.
Take your pick.
Yes, actually, I think that we will be needing to have a lot of cryptography and efficient cryptography in our lives. We can just see how when even Facebook and Google start saying privacy is the most important feature for us and are talking about end-to-end encryption for everything, we see that, okay, apparently we do need a lot of cryptography. And the reason for that is so in my studies, we learned about the precautionary principle, which I think is very important. So in chemistry, for example, if you look at a new drug or new pharmaceutical component, you would not deploy that unless you know the risks. And this is a very easy principle, but it has political scientists have a lot of amazing papers where they explain it in different settings. And actually, this is what the EU does for pharmaceutical problems. They would not put that on the market until the researchers say, we have these risks. We know what the risks are, and we can see the risks. And the problem is that we just deployed, let's say, a lot of technological tools without assessing the risks. I'm not saying that we have to minimizing the risks is the next step, but just assessing the risks is already very important. So I think this is where we are now, and now people trying to assess the risks. And when they assess them, they also think about how to increase or decrease in this setting the risks. And this is where we are going to need a lot of cryptography. And what I'm very excited about is that actually the cryptocurrency sphere is talking a lot about zero knowledge proofs because of Zcash. And so a lot of people who who are doing Ethereum things, for example, are interested in ZK snarks and stocks and what's different to bulletproofs and do we want a trusted setup? And I think this is so great. But what I always also think is that there's so much cryptography next to ZK snarks and zero knowledge proofs So I would love to see just a tech community focusing on a lot of cryptography and trying to put that in real world products. So we have homomorphic encryption, for example, and cool new signatures and multi-signatures, and also all the push quantum things happening. And we need to deploy that into more tech products to get society to not suffer under the precautionary principle, which we don't hold up to.
Yeah, I think even if the cryptocurrency thing completely goes away, there's going to be a huge net positive just because of the amount of money that's been thrown at cryptographic research.
Yes.
Yeah, absolutely.
That's one of the things that the foundation is part of their mission is that, one, we are supporting Zcash, the protocol, and the Zcash community, but also privacy technology research in general. So Henry de Valence, one of our research scientists, is doing a lot of research in secure implementations of elliptic curve groups, prime order groups. And that technology can be used way beyond anything related to cryptocurrencies or privacy. It can be used in any usage of a prime order group in cryptography. It doesn't even have to be one that was originally designed for elliptic curves or something like that. So I completely agree. If cryptocurrencies kind of come and go, I think there will be a massive trickling out of influence about applying high efficiency technology, both pseudonymity from other cryptocurrencies and real private zero knowledge proof based technology, and lessons learned about how to make these things efficient, deployable, usable by real people, and how to make sure that they stay secure in many different situations, because Zcash uses zero knowledge proofs and ZK snarks in a certain way, but that's a different way than the way that Monero tries to stay secure and private. So I think it's going to have an influence for a very long time, and hopefully for the good. Even hopefully not good if our cryptocurrencies don't live forever and ever.
Which would be very sad. But also what I was thinking when you were asking the question of how society should perceive or not perceive cryptography, and how cryptography influences society. I was thinking that actually recently I was talking to a professor and who's not that much research in cryptography, but just in general privacy. And she then mentioned that privacy, different people have a very different definition by privacy. Mm-hmm. And when she said it, I was yes, true. I perceive privacy as absolute confidentiality and data minimization. If some part of my data is leaked, I'm oh no, that's so bad. And I think how to minimize the data. But she mentioned that a lot of people perceive privacy as control over the data. So they're fine with sharing data as long as they have control and they know what's happening.
For example, their medical information. They have to share it, but they really want control of to whom and when and that they actually share it.
Exactly. And cryptography enhancing the first definition of privacy is confidentiality. Whereas I think we can use tons of cool cryptography to help everybody who's thinking privacy as control and who thinks it's fine for me putting this picture up on a social network, and I want to help those people as we want to help those people, I think, as well.
Yeah, I talked about this earlier with Amber and Patrick from Clover, that there needs to be a lot more privacy by default. So you can still give people the option, if you don't care about privacy or if you don't want it, you can undo it. But right now it's if you want privacy, you can actually achieve it to a reasonable level, but you have to have a lot of technical skills.
Yeah.
And so making that the default in applications
and
is really important.
Even if it's not about technical skill, it's not the default. And so a lot of people don't even know about it, period, or they won't use it because they just do the golden path, the first thing that they're presented, and that's what they get used to. For example, Venmo payments, you can have them all private and no one knows about it except you and the person you're transacting with. It's not end-to-end encrypted or zero knowledge proofs or anything like that, but it's just not out there in public for all of your connections to see. But people don't realize that they are public by default. They don't realize there's an option to make them private at all. Similar, Facebook Messenger has end-to-end encrypted with the Signal protocol private conversations. I have a feeling a lot of people don't know that exists. You can use that from your mobile device to your mobile device. You can't use it on the web browser implementation of Facebook Messenger, but it exists. It's very secure. They even have excellent cryptographic features to let users report abuse via end-to-end encrypted messages to Facebook. And Facebook can't, you basically unwrap a message to prove that it came from the person that you're reporting against. It's called message franking, that I don't think I've seen in any other end-to-end encrypted messenger. And I have a feeling it's not as well known that you can do this on Facebook Messenger, and Facebook Messenger is huge.
Also, I think that's like exactly that solutions is like something that is like sometimes overlooked by the community or the communities who like look at privacy and security. So, because like a lot of people are like, oh, you know what? Like, don't use like the social network, don't share, you know, this photo. And which is absolutely like, I mean, yes, like if you really care about like this thing, you should not.
If you don't want to have a social life.
Exactly. And I think that they're like, oh, just use this complicated subtool or something. And I think that's very elitist because people have not like, they don't have the skills, they don't have the time, and they have like a lot of different things they're like thinking in their lives. And I think it's very important for us to concentrate, like to make something usable. That's something that the Zcash Foundation cares about, to have a usable, good cryptocurrency. We're like on the path to that, even like, yeah, it might be a bumpy road, but that's like a goal.
Yeah, I have the impression like the Zcash Community Foundation in general puts a lot of thought into stuff like the precautionary principle and stuff like that. And like, I know I've never worked in like application startups before, but like before I was in satellite launch, and it's like the same thing. Like once it's out there, like there's not really anything you can do to fix it. And so like we kind of have to think the same way with these protocols. Like once you put it out there, if it's broken, then like a lot of people could be fucked.
And same with the software, not even just the protocol, but like, it's like a meme at this point with like cryptocurrency stuff is like, this is untrustworthy software. It's like a prototype, like do not use this if you care about your money or whatever. And then someone forks it and then they're like, this is our new cryptocurrency and it's live right now and people put their money into it. So that's one of the reasons the software has been in the open since Parity started on it for Zebra. But like we want to do our best to say, you know, the software from the foundation, we want to make sure that we trust in it before we say people put your money in it and call it 1.0 and say like it's live, it's like official.
Yeah, with this governance stuff and like we talked about cryptocurrency maybe dying, but one of the...
for the record, I don't think it's actually dying. I think we're just in a little bit of our own little world. And so we're always like afraid that our cool thing is going to die or something.
But one of the nice things is like, I mean, we talked about TLS earlier and like you get a bug that affects everybody. The cryptocurrency can actually provide an incentive for people to work on it.
Yes.
Which like these other open source protocols, you're just kind of counting on some guy doing it on the weekend.
Yeah. And like for the case of OpenSSL, the project, it had like one or two people working part-time as like the people who were maintaining it, even though major corporations all over the world were like extremely relying on it for years. And only when Heartbleed hit did people realize that they were undermanned, even though they were a critical part of internet infrastructure. Now, OpenSSL as a project is a completely different beast. They have so much more money. They have so much more staff, full-time staff who maintain it, and they've completely cleaned up their code, their documentation. There's still stuff to fix in OpenSSL because it's a large, complex C code base, but it's worlds different than it was when Heartbleed happened. Luckily, in cryptocurrencies, we have all these different structures to finance both the projects and to incentivize people to work on them and to keep them safe and make sure that they're secure, and also to make sure that they're fast because otherwise people won't use them, and so on and so on.
Yeah, so quantum security.
Okay. Yes.
One of your passions, Deirdre.
Yeah. Typography is my passion. Also post-quantum cryptography.
So what is the threat of quantum computing? Because most people think like you break the private key and that's it. But like what is like the real threat model?
The real threat model of a sufficiently large, efficient quantum computer coming online mostly is people logging traffic or other encrypted or protected by asymmetric cryptography in some way, logging a bunch of your data over time right now. So like you can just sit on the internet backbone, for example, and slurp up a bunch of secure, like, well, I guess for blockchain, you keep the blockchain history forever and ever. But in the case of, for example, TLS, your connection is secured, established by doing a asymmetric cryptography handshake, such as elliptic curve Diffie-Hellman. And then from that, you derive a symmetric key, and you use that to encrypt all of the messages that you exchange over that channel. And then you break the connection, and that all of that data should be poof. Everything that went over the wire should just be thrown away in the bin, right? But if you're sitting on the wire and just recording all of the encrypted traffic, including all the handshake messages, you can just stick them in your very large database in your data center in Utah that is being funded by the federal government and just save that for years until you bring your very large efficient quantum computer online. When you do that, there are multiple quantum attack algorithms for elliptic curve Diffie-Hellman and other pieces of classical cryptography, where classical cryptography is everything that we're using now in the real world, including pairings, including any kind of Diffie-Hellman, except for supersingular isogeny Diffie-Hellman. And there are attacks against symmetric cryptography such as AES, but they're far less powerful. So the threat model is anyone who can afford to buy or build a sufficiently large quantum computer to efficiently run these algorithms, who has something to attack, such as a store of protected data like TLS connections or public data like a blockchain. And then they train their quantum computer to run this algorithm against a key exchange specifically to break the private key of an elliptic curve public-private K-pair or other kinds of Diffie-Hellman or a signature or something like that. And then they're like, ooh, cool, I can decrypt all of that traffic that was encrypted underneath this key exchange. Or, oh, I can break any part. So if there are parts of the sapling private transactions that rely on doing an elliptic curve Diffie-Hellman key exchange, not a key exchange, but they do a handshake. If they can break that part and they can break the pairing part and they can break all these other parts, then they can decrypt your encrypted notes and things like that. So they're not going to become efficient enough to buy one and put it in your house for a very long time. But the way that the research is going amongst the many physicists and computer architects and scientists and, theoreticians who are working on this across the world, who are getting a lot of money invested into this, such as at IBM and Google and other companies like D-Wave, is someone who has a target, a collection of data that is possibly high value, either a bunch of TLS connections or a blockchain or something similar, or if they have a single high value target who they, intercepted their hard drive or their phone or something like that, they can train their computer on that. The way things are going, there's a meme among quantum computing that quantum computers have been 10 to 20 years away for 10 to 20 years, and they're not quite there yet, but they're never stalling. There's never a lull in the progress between we can break, we can factor a 15. Like we can factor a composite of 2 primes, except that composite is 15 and we factor it into 3 and 5. Like, ooh. But we've got 50 to 100 physical qubit quantum computers now, not D-Wave quantum annealing computers, but like real qubit computers now. And the progress keeps increasing. It's not Moore's law increasing, but it's kind of getting there, instead of like the number of qubits doubling on a processor every 18 months, which is about what Moore's law used to be. I think it's about every 2 years at this rate. So that is the threat from quantum computers. I would say don't rewrite everything and throw it out the window and hide under your bed now. But don't keep your eye off the ball for the next 10, 20, 30 years.
And don't put your private data just encrypted and put it in a public place, because you have to assume that will be broken.
Yeah. So one of the things that people are trying to work on when trying to develop new quantum resistant cryptographic systems is we actually have a lot of theoretically quantum secure systems, like 1 million bit RSA, like that is quantum resistant. Like you are not going to train your quantum computer against 1 million bit RSA, but no one will use 1 million bit RSA, not in a blockchain, private blockchain implementation, not for TLS. Maybe if you really, really need to keep something secure right now and like encrypt it and like put it in a vault or something like that, you could use 1 million bit RSA, and that would be fine. It's a one-time computation and maybe a one-time decryption far in the future, and you would probably be safe. We need to figure out, and there's a lot of vigorous work going on in this area, efficient, time efficient, and space efficient quantum resistant algorithms that can be used to drop into the applications that we use cryptography in now. So there's a lot of interest in replacing key exchanges and signatures. There are many avenues that people are approaching with pluses and minuses. Sometimes they are very fast, but they're huge bytes on the wire, or vice versa. But there still needs to be a lot of work done to find quantum resistant zero knowledge proof systems that are, fast and succinct.
So my understanding before was that like if quantum computers come in and change things and they can like crack these, say, 256-bit keys, then you just make a bigger key. But I think you're saying like the algorithms are fundamentally different. Like you need to design a new way to make a signature.
You can make a bigger key for AES and other symmetric primitives. So for hashes, for block ciphers like AES and Cha-Cha and things like that, you can just basically double the key size. So for AES 128, you double it to 256 and you're good to go. Because the best known quantum attack algorithms against those sort of crypto primitives are far less efficient than the ones that we have against asymmetric primitives. So the ones that we have for symmetric are called Grover's algorithm. And basically it's like a square root speed up against just, trying every single permutation you've got. So that's why it doubles from 128 to 256, because you have to account for a square root speed up. For asymmetric algorithms, for anything that depends on the discrete log problem or factoring, which includes RSA, Diffie-Hellman, and elliptic curve stuff, Shor's algorithm and variants of it are the biggest threat. And they basically, it's not a square root speed up. I forget what it is, but it's much worse. It's like if you double it, that's not going to take it into account. I think it's like it reduces it by like a factor of 10 or something like that. It's ridiculous, and I don't have the numbers off the top of my brain. You need a fundamentally different primitive or math problem to base your asymmetric cryptography on to be resistant. So for example, the leading candidates for asymmetric key exchange include lattice-based cryptography, things like ring LWE and other variants. There is isogeny-based cryptography. There's also systems, other post-quantum systems based on hashes and codes. And I think there's one more that multivariate. Multivariate is the other one. But the big ones for key exchange right now are basically lattices and isogenies. Lattices because they're extremely fast. Isogeny-based because the keys that you actually put on the wire are extremely small. Those are based on fundamentally different mathematical assumptions that are assumed to be difficult for quantum computers to attack. And by difficult, I mean we have not discovered a quantum algorithm that we run on a quantum computer that is efficient against trying to break these cryptographic systems. So that's not to say that we will never find an algorithm that runs on a quantum computer or a classical computer to attack these new, possibly quantum-resistant problems. But for lattices and for isogenies, but there's been a minimum of 20 years of research to see if we can find something to break them, and so far we haven't. So
I really like that you say quantum resistant.
Yes.
Because there's these algorithms and these primitives are called, a lot of people in cryptography call them post-quantum, which I always found weird because the idea is that we use current day classical computers to use these algorithms to secure our data now with these problems that Deirdre mentioned, like lattice-based or isogeny-based things. And this is called post-quantum because it's secure in a post-quantum world against quantum computers. But I think quantum resistant is a much better term. Yes. Quantum algorithms, though, are actually algorithms which use quantum computers to secure your data.
Yeah. And people are working on quantum computing, not just to try and break all the cryptography we use today. Quantum computing theoretically will be very useful for simulating complex processes such as protein folding, which can be very useful for medicine and pharmaceuticals, for fluid dynamic simulation and for weather simulations and nuclear physics simulations, things that we throw lots and lots of data center compute at now and do okay. But if we can get a quantum computer who has this fundamental quantum physical kind of interactions that or more closely related to these systems that they're trying to model and process. That's a bigger reason that people are trying to develop these computers, not just because they're stealing all your data and stockpiling it and, trying to decrypt it later. And like, they're not trying to attack all of the, cryptocurrencies and steal your data. That is not a wise investment. It's like, oh, we're just going to invest in quantum computing and break all the blockchains. There may be certain parties that have 3-letter acronyms that have this sort of purpose in the back of their brain, but that is not generally where most of the investment in the broader business community seems to be. It seems to be for these other more generic purposes.
So yeah, should we turn the Zcash Foundation to a quantum organization?
No, I don't think we have that much money or expertise.
No, but as you see, the Zcash Foundation itself is everybody's very keen on any kind of cryptography, and we're interested in what's happening. So don't worry, we're not going to do now quantum computer stuff. We're just interested. Yeah, it's really cool.
I mostly for example, we had a speaker here at the end of the morning session here at ZCon 1, where he was discussing a new result about a different construction of snark that is based completely on symmetric primitives. So it's all hashes and other, random oracle stuff. So that means that theoretically it is completely quantum resistant to all known attacks. So we have other snarks and starks, not starks. We have other snarks, but they're all based on classical asymmetric assumptions at the moment. Things like pairings that are used in sapling and stuff like that. There are starks, which are not used in Zcash, that are also theoretically quantum resistant because they're also completely based on symmetric primitives. But to have another one with a good security proof behind it is very exciting. So part of my interest at the foundation is to keep an eye on the evolution of zero-knowledge proofs that may be quantum resistant and see how they may be applicable in Zcash as we evolve the protocol itself, or in a similar kind of Zcash adjacent application, either in a cryptocurrency or other privacy technology, if they prove to be efficient and useful now. Because if they are similarly fast, similarly succinct as what we're using now that's all classical based, I see no reason to experiment with that adoption of a possibly quantum resistant primitives. So we'll see. We'll see how it goes.
Yeah. Is there anything else that you guys want to talk about?
Actually, just how is it at Parity now? Is there a huge duel between two podcasts, Joe?
I don't think so, because this was Fred's idea.
Okay.
Very
so good. Zero Knowledge started 2 years ago, and Fred was like, we should have a Parity podcast.
Yay.
And everybody ignored him. So he and Anna just were like, okay, we're going to start it ourselves. And then 2 years later, I think Fred said again, we should have a Parity podcast. And we said, okay. And we're actually using Fred's personal microphones and recording equipment. So
hi, Fred.
Thanks, Fred.
Yeah, thanks, Fred. I don't think there's too much of a duel here. Otherwise, he wouldn't have given them to me.
Well, I just want to say thank you, Parity, for giving us Parity Zcash now that we're calling it Zebra. Without you, we wouldn't be where we are.
Big thanks.
Yeah.
Yeah. Thanks to you guys for coming on and for ZCon. It's really fun.
Yeah.
Yay.
And it's an exercise to the listener to go look up the name of a baby zebra.
And tell us.
Yes.
Later.
Send us back.
Yeah.
Yay.
Thank you very much.
Thanks.
Thanks for listening to Relay Chain. We'd love to keep in touch. Follow us on Twitter at RelayChain or email podcast@parity.io. Our team at Parity includes some of the leading peer-to-peer networking developers, consensus algorithm inventors, blockchain innovators, and Rust developers. If you want to learn more about our work or want to work with us, visit our website at parity.io and sign up for our newsletter at parity.io